Hello students, welcome back. Let us return to section 1. We went through up to 1.6. Now let's go to rotation identity 2, rotation by plus or minus pivot 2, or 90-degree rotation. This is by far the trickiest. Well, alright. Sine of theta plus pivot 2 is cosine of theta, and then minus pivot 2 we get negative cosine. Cosine of theta plus pivot 2 negative sine. Subtract pivot 2 we have sine. For tangent and cotangent it's easier, theta plus pivot 2 or theta minus pivot 2, either way we get negative cotangent. So tangent and cotangent part is definitely better, but as for sine and cosine part, they're really confusing. And as for the graphs, let's see, can you see those behavior? Red graph here, sine, and then shift it left by pivot 2 to become cosine, so that's plus pivot 2. And consequently, green shifted by pivot 2 to the right, becoming sine, so that's this minus pivot 2. And then let's see, from this red, if I shift this to the right by pivot 2, then we get this green, and that's not cosine, that's negative cosine. Yeah, that's what I'm looking at. And so on. So, okay, alright. Graphs do exhibit those behavior, but still confusing. Well, there's no easy way. Sine becomes cosine, cosine becomes sine whenever pivot 2 is involved. But pluses or minuses, it's really hard to remember, so look those up. Alright? And as for the proof, here we go. We have to do this at some point, so let's do it now. Alright, look at the first graph and the second graph. First graph, angle theta, and then the second graph, angle theta plus pi. Theta plus pivot 2, excuse me, plus 90 degrees. So here, third quadrant, and then pivot 2 more. So we ended up with theta plus pivot 2, 90 degree more. So don't pay too much attention to this right triangle, as a matter of fact. Okay, if you pay attention to this right triangle, it's going to be mapped over to this dotted right triangle, but this dotted right triangle is not in the center position. Preferably the right angle should be on the x-axis, so redraw it here. That's the kind of thing. But as a matter of fact, if you just look at the angle alone, this radius here is moved to that radius over there. So it's just theta plus pivot 2. So from blue to red, that's how it went. Now, okay, all right. Now let's consider sine of theta plus pivot 2. How does that behave? Well, theta plus pivot 2, after pivot 2 rotation, I'm looking at this red. See that? So I have to get y over r from the second picture here. And I have to highlight this as red because I'm getting all these from this red circle. Alright, first graph blue, second graph red. I want sine, so y over r, but y coordinate is coming from the second graph, red. Now, how can you express these quantities in terms of the quantities in the first graph? This y coordinate is same as this x coordinate here, so it's x1 over r, but be careful. How about the sine? Negative staying at negative. So alright, no change here. So x over r, that's cosine. Here, y2, so y-coordinate of the second picture, and x2, x-coordinate of the second picture, same quantity, same sign, so x1 and y2 are the same. These two are the same, so I don't have to change anything. What's happening here? And we just ended up proving this one. Let's see, can you do something to cosine and tangent as well? Please stop the playback and try. We have to start from this red circle. Cosine is x over r, so express it here. And express those x-coordinates in terms of quantities here. Good luck. For tangent, we need both x and y. Got it? Well, alright, here's the answer key. Cosine of pi over x theta plus pi over 2 is coming from this red circle. So it's x over r, but it's coming from the second picture. So x-coordinate of this second picture, so it's x2 over r. And what is this x2? It's same as this y-coordinate of the first picture, but opposite sign. This is negative, that one is positive. So we need this negative. Take the negative out, y1 over r, so negative of sign. As for tangent, there you go. y2 over x2, because both are coming from this red graph, red picture. And then y2 and x1 are the same. And y1 and x2 and y1 are the same, but opposite sign. So after simplification, you get negative of x over y. It's cotangent. Now, will those relations stay the same in different quadrants? Well, you may have to do this 3 more times, but let's do it just one more. So previously, third to fourth quadrant. Here, second to third quadrant. What do you see? Radius always stays the same. X became y, and x1 and y2, they're the same. X coordinate of the first picture, y coordinate of the second picture, they're both negative, they're the same. And then y1 versus x1, they're opposite. y1 over x2, excuse me. So y coordinate of the first picture versus x coordinate of the second picture, they are opposite. So x2 is negative y1, and then previously y2 and x1 are the same. Exactly the same thing goes on. Even if you get first and second quadrant or other, okay, first and second quadrant, again the same relation will hold. In order to make sure, you have to do it 4 times for each quadrant. 1 to 2, 2 to 3, 3 to 4, and 4 to 1. I'll just show you only 3 times. Okay, alright. So we ended up proving the first line. Now how about the second line? Well, now let's go backward. We start from the right hand side now. And that's my first picture. And the left hand side is my second picture. And then, for instance, previously we did sine, so let's consider cosine, all right? Now, let's stick to sine. Sine of theta minus pi over 2. And, angle theta, that's the first picture. Theta minus pi only up to here. So this is coming from second picture, blue. And then sine of this angle, theta minus pi over 2 from the first picture. So y over r should be coming from the first picture. And that's expressed in blue. Now compare first picture and second picture. This y1 is same as x. Excuse me, I wrote it wrong. This is a second picture, all right? I'm moving right hand side to left hand side. So this is second picture, sorry about that. So y coordinate of the second picture, blue, over r. And that's the same as the x coordinate of the first picture, except that it's negative. And this is coming from the first picture, red. Remember, this time, right hand side to left hand side. This is the first picture. This one is the second picture, right? Once you get here, it's easy. Take negative out. So this is negative of cosine of theta. That's red. And then original is red. Can you do the same for cosine and tangent functions too? Well, stop the playback and try. Here's the answer. For cosine, here's the answer. We begin from theta minus 2, second picture, blue, and x over r, but x coordinate of the second picture, so x2 over r. But this x2 is same as this y1. Same sign, same magnitude. So y over r, that's sine of theta. And then you can do the same thing for tangent as well. And then the same relation applies to other quadrants too. Alright, in conclusion, we have these rotation identities. Rotation by pi over 2 or minus pi over 2. Sine becomes cosine, cosine becomes sine. Tangent becomes cotangent, cotangent becomes tangent. Secant becomes cosecant, cosecant becomes secant. Great, but pluses and minuses, well, always confusing, so always look them up. As for the previous rotation identities, plus or minus pi, sine stays as sine, cosine stays as cosine, tangent stays as tangent, but pluses and minuses can be confusing, so look those up. Maybe not as confusing as pi over 2 rotation, but still. Enough time for 1.8 and 1.9? No, not really, so let's stop here, and we'll complete it in the next video.